Among the various reduced voltage startup methods for three-phase asynchronous motors, the star triangle reduced voltage startup is one of the most widely used techniques. How can we utilize an S7-1200 PLC to develop a control system for the star triangle reduced voltage startup of a three-phase asynchronous motor? Let's first outline the key technologies involved in creating this control system, the use of S7-1200 timers. The S7-1200 PLC offers 4 types of timers. 1. On-delay timer. 2. Retentive on-delay timer. 3. Judgment delay timer. 4. Pulse timer. We will focus on the on-delay timer, which is commonly used in applications. The timer relies on a structure stored within a data block to retain timer data. When placing a timer instruction in the working area, it is necessary to allocate a data block. Let's familiarize ourselves with the functions of each pin and parameter of the timer. 1. Timer number and background data block. 2. Enable input IN. 3. Preset timer value PT. 4. Current value ET. 5. Output Q. Next, we will use a set of timing diagrams to illustrate the working process of the on-delay timer. For the on-delay timer, when the enable input IN is activated, the timer begins to count, and the current value ET increments. When the current value ET reaches the preset value PT, the timer's output is set. The timer ceases to count and retains the current timer value. If the second enable signal is closed for a duration shorter than the preset value PT, the timer's output will not operate. When the enable input IN is deactivated, the timer's current value and output status are reset. Now, let's work through an example of using an on-delay timer. When I0.2 is continuously activated for 5 seconds, Q0.5 should be activated. Please write the control program accordingly. Our programming approach is as follows. When I0.2 is closed, the timer T0 starts timing. Upon reaching the preset delay of 5 seconds, the timer's output is activated and the coil Q0.5 will be energized. Let's monitor the PLC to verify our programming logic. When I0.2 is closed, our timer springs into action. Its process value gradually increases, and when it matches the preset value, the timer's output Q will close. Subsequently, the coil Q0.5 will be energized. We observe that when the process value equals the preset value, the output Q is activated, and then its coil Q0.5 is energized. This concludes our introduction to the use of the S7-1200 on-delay timer.